Hi, I'm Jack Burgess. Welcome back. In my last video, I talked about building all the maintenance away cars that were on the Yosemite Valley Railroad in August 1939, which is the month and year that I model. I showed 10 of the 11 cars, and at the end of that video, I talked about a crane that I was working on. After that video, John and I talked about that if the car was done in time, we could show it on the next video, which is this one. And so that kind of gave me a deadline, and I tend not to work against deadlines, but I really wanted to get it done, and so I actually finished it 3 days ago. So you're going to get to see that car. In that last video, I also mentioned that I was waiting for a number of parts that were being 3D printed, which I got the very next day after that filming. So the work went okay. I had some real challenges still, but the final crane came out fairly well as far as I'm concerned. I first painted it with Floquil weathered black. Yes, I'm still using Floquil. Once I get into a product, I want to use that for the rest of my life type of thing. And so when I heard Floquil was going out of business, I bought about $200 worth of Floquil, the colors that I use most. Boxcar red, black, weathered black, so forth. I still have a little bit of black and weathered black, enough for doing one other car. I don't know what it would be. But I'm just very comfortable with Floquil. Someday, maybe I'll try something else. But anyway, so I painted it with weathered black first because as an all black car, it kind of disappears. And photos tend to show that the roof was pretty light, and so I thought, okay, maybe I'll paint weathered black on everything, and then I'll overspray the body portions with regular black. And I did that and immediately realized it wasn't going to work. And at that point, the roof was not on. I painted everything because I basically painted things and then put them together. There's no way I could paint the whole thing once it was assembled. So then the next step was obviously do decals. I made decals for every single locomotive, caboose, passenger car, freight car on the railroad. About 30 years ago I started them. And I sell them through my website. Some of them have been sold out. I had them all printed through one firm that is no longer in business but has been purchased. So I don't know if I'm going to order more. I doubt it. But I don't know how I did these because I had no dimensions. I didn't have that many photos, but they fit perfectly. So I was just really lucky there. But I also had a decision to make about what lettering scheme to use. This particular photo was taken in 1937, and the lettering, as you'll notice, is sans serif. In other words, no little tails on things. I was really thinking about using that because it would be the only car on the railroad with that particular style of lettering, which was kind of an attractive idea. But then I had this photo, which was taken in 1940, and it has the serif style lettering. What you look at both of those pictures, the car looks like it's fairly well maintained. I have one more photo that was taken in 1938 when they were cleaning up a huge flood on the railroad, on the upper end of the railroad, and it is really dirty. But then the 1940 photo shows it freshly painted. So that led me to think that once the damage from the flood was cleaned up, the crane was repainted that winter. Maybe they only painted the body and they didn't paint the roof. I wasn't going to go that far. That would be kind of weird. But I did weather the roof more to kind of show that idea. So I've had this issue on a lot of equipment where I have a real early photo and then I have a very late photo, and then trying to weather the car as it was in 39 is sometimes hard. Another thing I did on this project is the thing I do on all projects that take a lot of time, that I need to make sure I do all the steps. I've done it when I was making all the flat cars or building all the flat cars, did it when some other projects, and that is to have a list of steps that I need to take. And I do it on my computer. I've always been a person that makes lists and likes to cross things off that list. One of the things I had to make sure I didn't do is there is glass in the window in the door, and I had to put that in before I put the roof on. So this list was probably 30 steps long. Things I would think of that I got to do this before I do this. When I do this, I got to remember to do this. And so that kind of thing helps when you're working on something like this. If you miss it, if you take a step out of order, it's all over. A minute ago, I talked about weathering this piece of equipment. I will admit that the first time ever in my career building stuff, I was petrified about doing that. It was all painted, assembled for the most part, and after spending so much time on it, I was afraid I would mess up the weathering. Keep in mind that of all the equipment I've built, resin kits and scratch build YV stuff, most of it is not weathered heavily. I've got a photo that was taken in 1942, I believe, from a caboose showing a string of freight cars, including a couple YV cars and some foreign cars. Some of them have the paint is weathered, but not really dirty. During the war, there was so much traffic on railroads that they did not wash their stuff. And so that kind of led to this idea that stuff should just be really grimy. And today, of course, I won't even look at trains because there's graffiti, and once they're built, they're never painted again, I don't think. So what I did finally is I painted up some pieces of styrene, and that let me practice using pan pastels, which is what I was going to use on this. A lot of other equipment, what I'll do is I'll paint it, put a gloss coat on it, put the decals on, put a flat coat on it, and then overspray it so that the lettering fades out. Maybe the color of the paint fades a little bit. This one I didn't do that because, based on the photo, the lettering is crisp. It was only a couple of years old. So these little pieces of styrene let me practice, and I painted 3 of them. I expected to spend an hour trying things, using them all. This told me that this color is a little bit too light. So then I went through and did this, and 15 minutes after I started, I got my courage back, realized I didn't need to worry about it, and went on and weathered the entire car. So in situations like that, say maybe even spray painting or airbrushing, and you're not that comfortable with it, and you have a car that you really want to have it work, is take some styrene, take it in your paint booth, paint it, try it, go on, spend an hour if you need to, and then when you feel comfortable, paint the car. Very last thing to finish the crane was the rigging. First task was to find thread or something to be used. I actually had some material that may have been in a kit, but I don't remember buying a kit, and it looked pretty good. So we actually took that. My wife and I went to a fabric store because I'm afraid of fabric stores, and got somebody to help us, and we could not find anything that was thick enough. It had to be black. We didn't want fuzzies on it, so forth. So then my wife took this task on, got on Amazon, and bought every single thing she could find that might work, knowing that they could all be mailed back for free shipping both ways. And so she found this. This is thread used for upholstery. It's a little fuzzy, but it's the right size. And so that's what I used. So then the question was how to actually rig it. And so I'd already put this material thread around all of the drums, all 3 drums inside. And my original thought was I'll go around and around the drums and then leave a long piece out so that will become what is going to be rigging the boom. That was not practical. So what I had to be able to do is take a piece of thread and get it on top of the drum and glue it in place. So I made this little tool. It took me about 5 minutes. You can see it was made out of a pencil. And then this is a piece of brass. I heated it up red hot, smashed it so that it turned into kind of like a spoon, gave it a little curl. And so what that let me do is take a piece of thread, take tweezers, stick it on top of the drum, put some glue there, and then push it in and push it around to the back side of the drum, and then let it dry. And I was using canopy glue for doing all this stuff here, and actually timed it because canopy glue says, I think it says 3 hours to dry. For this kind of stuff, it took 27 minutes. And so I used my phone. Every time I would put a piece of glue on something, I would set a timer on my phone, do something else, watch it. When 25 minutes was up, or 23 or something, then I knew I could go on and do the next step. So what I did then is glued a piece here, pulled it out. I had this laying on a couple of pieces of wood, so I propped it up. And then the trick was every one of these lines needs to have the same tension. If I put 4 of them in and then I put one in that has a little more tension, they will all go sag. These blocks out here, I could have done them in 3D. These are some white metal castings that Eric Bracker from Rio Grande Models sent me. And I used those because I needed just a little more weight to kind of make sure everything was okay. So I'll show you in a minute how this is rigged, but there's a couple lines coming up and so forth, and then they go around these back here, all in an effort to reduce the pull on the cables. So the drums down here, or the blocking, is all running off of one line, which goes to a second drum. But to lift the boom is all of these guys. So let me show you how this thing is actually done. So what I want to do now is show you the rigging. And I don't know if I said, but it took me a long time to figure out this rigging, and I finally figured it out not that long before I had to do it. So these are elements from my 3D print of the boom and the interior, but I printed this and I made prints and thought about it and would sketch on what I thought was going on. I thought initially there was one rope coming out of here and it was doing all kinds of stuff. It wasn't. So I'm 99% sure that I'm right. So this is the drum for lifting the boom. You've got 2 ropes coming out. They go under these 2 outside pulleys, over them, over these 2 pulleys, back, under the inside pulleys, and then around the horizontal pulley right there. So when you turn this, all of these things turn and the boom has to come up because you're taking rope in here, and what all of these are doing is giving you an 8-to-1 advantage. So in other words, if you had 1,000 pounds out here, this is pulling 1/8 of that. That's the update on Crane 08. Looking back, I actually started working on this back in 2007 when I started writing letters to researchers trying to get more information. So it was a long, drawn-out project. Drawing plans for it was a lot of fun. The construction of the crane was a challenge at times, but it was a very satisfying project in the end. So now I want to talk about soldering. Like the other tools I've talked about, I'm not going to show you how to solder, but I want to show you the tools that I use, give you some ideas. I will demonstrate some ideas that maybe you might think about. I first got experience on soldering back in the late 1960s. In those days, you had a power pack to run your train. You bought them at the store. All they could do is go faster, slower, or reverse it. Then people started taking advantage of the Silicon Valley movement and designing throttles that would have momentum, they would have braking, all these kinds of things. And finally, one was designed by Lynn Westcott, who was the editor of Model Railroader magazine, called the TAT4. TAT means True Action Throttle. I don't remember having a circuit board. There were stores called Radio Shack all over the place, and you could buy all the electronic parts you needed there. And so I built one, and it was pretty cool. But about the same time, I was helping a friend of mine on a project to restore a steam locomotive. It was the Hawaiian Railway number 5. It was purchased by Bob Keller. Some of you might remember that name because Keller later came out with a throttle called the Keller Onboard, which lets you control different locomotives on your layout. This is before DCC. So it was kind of the predecessor to DCC, but a total different idea. And so I was helping my friend. He worked for the company that actually rolled a new boiler for this locomotive, and they took it down to a place called Alviso, which is now all high-tech. In those days, it was open fields. He leased a little piece of property. We had this steam locomotive out near the main drag going through there. Never had problems of people messing around with it, unlike it would be today. And so what he was in charge of was all the piping in the cab and all the appliances. And I helped him by getting a tool, I think. But I learned a lot about what every single item in a steam cab did, the throttle, the Johnson bar, all the valves and so forth. And so that got me interested in the idea of building something that took the electronics that I had already built and let you control a locomotive by pulling the throttle and not turning a knob. And you might remember on one of the previous episodes I talked about I had a layout that to throw the turnouts, you actually had a miniature switch machine and you lifted it and so forth. And so that was the era that this was. So not only did you turn the turnouts realistically, but I wanted to be able to do that to operate their train. So this is the result. A 1/4 full-size steam cab backhead. It was basically all scratch built. I did buy one live steam valve and made a pattern and cast these guys. The problem with what I did is I've had children come over. It's very accessible right now, and they break them off. Usually they put them somewhere and I can glue them back on. But everything works. The throttle controls the speed, just like in the steam engine. This controls direction, that's forward, this is reverse. But it also, on this model, controls the acceleration rate. So this is neutral. When you start up a locomotive, if you have a large train, you drop it in the corner. That gives you a lot of power. But it also takes more fuel and more water. And so what the owners of the railroad want you to do is once you get moving, you'll notch this up. And this is called the company notch. It takes very little water, very little steam, but keeps you moving. If you go into reverse, same thing. This takes more power, or gives you more power, and this doesn't. And so on the model, this controls the acceleration rate. So you drop it in the corner, like you should, you pull the throttle, and the engine starts moving very slowly, no matter, you could pull the throttle all the way out, and it's just starting to move, just like the prototype. As you get going, you can notch this back and pull this up, and now the acceleration is less. If you've got a switcher, then you wouldn't even drop it in the corner. You'd go from neutral to forward, pull the throttle, because you want quick acceleration. You're only pulling 2 or 3 boxcars. So this duplicates all of that. So this is the brake, this is the run position. The position here is the release. So if you've set the brakes, this will release the brakes, go back into run. If you drop 2 notches, that's the service. So now you're applying the brake. If you want, what you would actually do is apply a certain amount of air pressure, and when you get what you want, that holds that. That's lap. If you really mess up, that's the emergency. You're stopped. On the real thing, you're going to stop quicker. On the model railroad, you would stop really quick if you're getting ready to run through a switch backwards or whatever. So this is then the independent brake. This is for the entire train. This is for the locomotive. And it simply goes from off to on, anywhere in between. So this is what you would use if you're switching again. You've got 2 cars, the air is not hooked up, so there's no brakes on the cars. So you would stop the engine by shutting down the throttle and applying the brakes. You'd hear the brakes squeak, screaming, squeak, so forth. It also used water. The water glass worked. It showed the water level. What I had behind it was a brass tube about this big in diameter, about that wide or long, and it sat back here, and what you were measuring in the water glass was the amount of water, or the level of water in this boiler that's back here. So you're going to be using water all the time, so you need to add water before it gets too low. So to do that, you would turn this knob, open it. You can push this forward, it didn't do anything. But this is called the injector. There's another one over here. If this one fails, the engineer has an injector. Good practice was that you use this every once in a while just to keep it, making sure it works. There was always two ways of doing things associated with a boiler. What if the water glass broke? You don't know the water level. So you have tricocks. You open this one and you should get steam. If you open the middle one, you should get water and steam mixed because you're lower. And if you open the very bottom one, you better have water. If you're not getting water there, you need to inject some. So if you use the injector on the model here, what that would do is open a valve and fill up your boiler. As you're running, the water's running out of a boiler into a holding tank. Now your tinder is getting low. If you go to a water plug on the layout, swing the water plug out, it turns on a pump and it pumps water from the holding tank back into your tinder. So as an engineer, you need to be watching your train, watching the water level, blowing the whistle, notching up if you need to. We didn't have sounds in those days, but there was a company that was coming out with the very first onboard sound system. And what they actually ended up doing is, and I bought one for the locomotive I had, was the sound of the chugging sound. They brought up their working model, which also had a whistle and a bell. And so I knew it was coming, so I added the whistle lever. I could never figure out how I could have a cord for the bell. You know, this locomotive and all the YV locomotives, to ring the bell, you pull the cord, like you still did today. But I never got that far. But to operate this, I actually built a stand shown right here in this photo. It was in the center of the room. You can look at it and you can notice that I was sitting on a padded seat. I had an armrest so I could actually hang out just like the prototype. So you're actually you feel like you're in a locomotive, running a locomotive. What that meant, I only had one locomotive, but it took a two-man crew because someone has to go throw the switches. So I could see all the track from that position, and you see part of the layout in the background of that photo. That was a predecessor to my current layout, and it was around three sides of the garage. And then I designed my current layout, and this was not going to be part of it because it required walk-around controls. So I had this on display in the layout room for a while. Eventually it took up too much room and I moved it into the room where people gathered while waiting to get in to see the layout. I wanted to share this backhead with you because I learned a lot about working with brass and soldering while doing that project. From here we'll go into some of the tools I'm using now when working with brass. Before I installed DCC in my current layout, I was using a system called progressive cab control, which involved a lot of wiring. And I had a fairly cheap soldering gun, little pencil thing, burned it up, destroyed it. And so then I bought this thing. So I've had this probably for 30 years now. Still works great. Sometimes I've got a little problem now that the light won't come on. You noticed a minute ago it was flashing. Now it's flashing again, but I noticed when I looked down it was off. I'm not going to buy a new one because it's not affecting anything. This one is no longer available. There is a current model that you can find online. This is a 30 watt, I think, and the new one is 70. It has a screen, so you can actually, this you can dial a temperature up, but I've never used it. On the new one, it'll show you the temperature in the screen. Not sure the price, but until this thing dies, I'm going to continue to use that. If and when it does go, that's what I'll be buying. So now I'm going to talk about this torch. I think I bought it because it was kind of interesting and cool, and it wasn't very much money, maybe 15 bucks or something. I do use it occasionally, not that often, but I'll show you how to use it and a good example of when it really works well. I'm going to be using flux. This is called Super Safe Flux. I've had it for a long time. This, I think, is used in industry. It is not what you can find at the hardware store. This is not only totally safe, when you get done, it's non-conductive, there's nothing left there, so forth. I've used for a long time. I don't keep that on my workbench. I keep this with a little reminder, and I put it on with disposable brushes like this, and I have one right next to my soldering station that I use over and over and over, and then when it gets kind of icky looking, I'll toss it and get a new one. I thought I bought this from Radio Shack, but I don't see a name on it, which would have been typical. It was $14. I think I've had it for 40 years now, and this is really nice solder. It's really small. I think I have some for my big soldering guns that is, like that thick. But this is what I use for everything else. So now I want to demonstrate using this torch. So this is a piece of asbestos. I don't think you can buy it anymore, but it is made for soldering on. I have it sitting on an open drawer, which makes it kind of nice. But they do have this available in some kind of material, so you're not burning everything up. So the first thing I'm going to do is put just a little bit of solder paste on, or flux on here. And then I'm going to take this piece of solder that we cut off and put it next to it. Now, why this works well in this situation is if you took a soldering iron and you tried to get around that, it wouldn't get everything hot as easy. So turn this on. If you watch right here, it's done. That quick. It also works in some situations to unsolder stuff. So I don't have that many times I need to do that, but when it comes up, it's nice to have, and it's not that expensive. Here's another little torch of sorts. This really works good with heat shrink tubing, and let me show you how it works and what we're talking about. This is a package of heat shrink. You can get it in different diameters. This is really small, and where you might use this is installing decoders or headlights in locomotives. So what I've done is I've taken a couple pieces of maybe number 22 wire. You don't need to wrap them together. They're not under stress. I put them together so they were touching, took my regular solder station gun and just touched the solder. And so these are soldered together. So now what you do is you cut a piece of tubing a little bit longer than the gap. Slide it on this way. Cover it. So now we turn this on. And it's shrunk up. Now it's doing its job. The advantage, you can do this, you could do it with a match, but this doesn't have a real flame that's getting out. It's heating up a metal in there. And so it produces the heat, but you're not going to burn the heat shrink itself. So that works pretty good. So let me show you 3 little gadgets for removing solder. I haven't used these in a long time, but when I was doing circuit board, that kind of stuff, they were really effective because sometimes you get just a little bit too much solder somewhere. So this is the simplest one. You squeeze like this, touch the solder, and if it's hot and still fluid, it'll suck it up. And I can hear it rattling in there. This is the next up. None of these were very expensive, but you have that ready for you, and if too much solder, bam, and it's gone. This is kind of an old-fashioned one, but same idea. This is brass, I guess, or something. Super wick. If your solder's still fluid, you can push this down and push it on it, and it will suck it up. And just keep pushing on it. And you can see a little bit of solder from the last time. When it gets used, cut the tip off, and you're ready to go. So now I want to talk about resistance soldering. This is a high-end method of doing soldering. It is not for everyday stuff. I had a resistance soldering machine a long time ago, and when I tried it, I couldn't, it just wasn't powerful enough. It takes a lot of wattage. So this is, I think I had a 200 watt resistance soldering machine. I gave it away. This is a 300 watt machine sold by PBL. That's P-B-L. People that are narrow gauge modelers know PBL, especially if they're SN3, because they only import SN3 locomotives and cars and all that kind of stuff. They sell a lot of tools, flush cutters and so forth. This is a $700 machine now. I don't know how much I paid for it when I got it. I used it a lot in building my crane. All of the soldering of the brass was done with a resistance soldering machine. When you get a big piece of brass and you're soldering even a little piece to it, you're not going to get it done with a little soldering station. There's just not enough heat. You need to heat up everything. This heats it up instantly, and I'll show you that. It's pretty cool. So it comes with two different attachments that are tied or screwed into it. This one, you clip this tube metal that you're going to work with, touch the probe to it, push the foot pedal for a second, and it's soldered. This one, has probes, and you can hold the stuff together, push the foot pedal, and ding, it's done. You don't want to push the foot pedal and then come up to it, because as soon as it touches, you'll get a spark. So this is the machine itself. It has a dial. Depending on how big the part is, or the thickness of it and so forth, you might want a setting other than the hottest. What I do is typically, if I'm using it a lot over a couple of days, I know what I want to do or what setting I want. If I don't, I'll try something out and try something. So let's give it a shot. Okay, so now I'm going to demonstrate the resistance soldering machine. I'm going to use the probe, and I've got a clip on the metal itself. I've taken solder paste and put it on this piece of brass angle. I've got my foot pedal ready. So you touch it, and it's done. This time I'm going to use the tweezers. So we clamp it down, hit the button, and there it goes. Done. I want to mention one more thing. I was talking to Fish about resistance soldering. This is a CD from PBL. It's done a long time ago. He says that the quality isn't that great. It's okay, but he tells you everything. He does what I didn't do. He's showing you how to use solder paste and solder, and he, as I recall, he takes a brass locomotive apart. He fixes brass cabooses with soldering, soldering them back together, so forth. You've got to get it directly from PBL, P-B-L. It's $25, and they have a guarantee on their website. If you do not learn anything, you get your money back. So I really highly recommend this. I learned a lot, and I've been soldering for a long time. So with that, I'll sign off. I hope you learned some things, maybe got some ideas that in the future you can think, well, I remember when Jack said that, maybe I'll try that, so forth. So hopefully we'll see you next time.
Make sure that it doesn't move too. Oh, it has moved.
All right.